Okay, so one of the great things about using a computer is that, well, or learning how to program a computer, is that you can program kind of anything you can think of. And with the current climate as it is, I thought it might be interesting to have a look at how social isolation can affect the transmission of a disease. So I'm going to try and simulate in Java a very simple set of circles that represent people, and I will infect some of them, and some of them will move, and some of them will socially isolate, and we will see what kind of effect this has on the population. If you have processing, then please feel free to follow along. I will try and explain what I'm doing as I'm going along, but I don't want this to be too long a video, so I will kind of rattle through this. Now, I've got some initial code just to get started. So I've got my setup function, which you always need in processing. We don't always need it, but it's kind of a standard. And I've got my draw function. So anything that goes inside setup will be run once, and then anything inside draw will run 60 times every second. And I've just told it to create me a window, which is this. This is my window. And I've told it where to put my window on the screen. So when I press play, it always puts it in the same place. Just so it is nice and consistent. So, what am I going to do? Well, the first thing I want to do is I want to create myself this kind of basic human who's just a normal human. So we're going to refer to this as an agent because obviously they're not human. They're just kind of representing someone that can have some kind of behavior. An agent tends to be a kind of typical word for something that has its own behavior but doesn't really have a name. It's kind of a generic name. So I'm going to create a new file here. I'm going to call it agent. Okay, and it's going to be a class of agent. Now, a class is basically like a way of giving properties and functionality to something that you can create lots and lots of. So it's a bit like a cookie cutter where you can cut the same cookie over and over again from dough. The class agent will allow me to make lots of agents using exactly the same kind of schematic, and we're going to write that schematic now. So agent, so when I create an agent, this agent function will be the first thing that runs, and my agent is going to have a position. So I'm going to give it a vector, a p vector, pos short for position, equals, no, let's set its position in here. So pos equals new p vector. So we're going to make a new p vector. So in Java, we always have to give the data type before us declaring the variable. So this agent, every agent I make is going to have a position, and that's going to be in the form of a p vector. A p vector is simply just something that has an x position and a y position, but it's bundled up in one variable, which makes it easier rather than two. And you can also do vector math, which makes your life a lot easier. So I'm going to say equals new p vector, and we're going to pick a random number. I'm going to pick a random number between the between 0 and the width of the screen, and I'm going to also pick another random number that goes from 0 and the height of the screen. So my random number can go from over on the side up to here, and its y position can go from right down here all the way to here. So I can pick any coordinate on the screen using this, and so it will generate in a random starting location. Now I've ended two brackets there, so that's good. So I also need to say this dot pos because I mean pos relating to this agent, whichever agent it might be. So this position, now I'm going to give every agent an ID. I'm not sure if it will be necessary, but it might help. This dot ID equals ID. So when I first make an agent in here, I'll have to say something like agent A equals new agent, and I will have to give it an ID number. So I'm going to give it 10 here, and that will create it. So I need to say that I'm having an ID up here in ID. So the agent has an ID, and we refer to the agent's ID as this.id, this agent's ID. This ID here we're passing in whenever we create an agent. So I'm passing an ID of 10 in here, and that is this ID here. So that 10 we're going to set to this agent's ID. Okay, this dot position, lovely. So let's create a function now to draw the agent. So display void. So we have to give, whenever we write a function in Java, we have to tell the function the return type, and void means nothing to return. So we're not going to return anything here. We're just going to run a procedure, not a strict function. So we're going to say we're going to fill this with some color, and we are going to draw a circle. Now my circle is going to be from this dot pos.x, this dot pos.y, and I also need to give this a width as well. So int width equals, let's say 10 for instance. And now what's really good is I'm going to draw this at the width, this dot w. Oh no, I put width. Let's change this to w. Width is a variable name in itself. For actually, I could do width as a constant. That makes more sense. This dot width, and that way, like, the position will change. Like, they will buzz around the screen and could potentially be able to move, but the width is going to stay the same. So I can have that as a constant and get around that. But because this is already a keyword, this when I make size here and make the initial window, this 1000 gets stored in a variable called width that's available anywhere. And I take advantage of it here to find out the width of the canvas. So if ever I was to change the width here, my code will be dynamic enough to kind of update itself. I'm going to fill these for now just with maybe, what should I do, 50, 50, oh, 50, 50 and 200. So make them kind of bluish. Okay, so let's take this and let's globally declare agent A, and then I'm going to say when I set up my code, A is a new agent, and in draw, I'm going to, well, let's just play this and just check that nothing's happening. Okay, it didn't give me any errors, which is great, and I can say now a.display, because we wrote display here, our agent knows how to display, so I should be able to say a.display, and voila, we have a randomly placed circle, and if I press this again, it's in a different place slightly. Is this, yeah, okay, cool. So it is, we're cooking. Now, this is pretty sad on its own. We need to make a little community. So what I'm going to do is I'm going to, instead of making one agent, I'm going to make an array list which can hold all of the agents that I want. So I'm going to say ArrayList agents equals new ArrayList agent. So when we create an array list, we have to tell in Java the array list what data type we're going to put in it. So that's what these kind of crocodile brackets are for. So I am telling it that I'm having the data type agent. This is an agent. This is what it is, and it's going to expect that in this array list. And if I try and add an integer or a float or a p vector, it's going to throw an error. I can only put in agents in here. So ArrayList agents equals new ArrayList agent. So I've got a list called agents. And now what I can do is I can do a little for loop. Let's put a constant up here of int agents equals, let's say, 100. Okay, so let's say for integer I equals 0, I is less than agents. I'm sorry, I've used agents here and agents here, which is really sloppy, but the agents in capitals is a what is it? Is a constant, whereas still not great, is it? Let's do agent count. That's nicer. Agent count. You're right. That was sloppy of me. I do apologise. Okay, so agent count I++, and then A equals new agent. Okay, so instead of saying new agent 10, let's give it the I that we used as its ID, because then it will be unique. They won't all spawn with the ID 10. The idea of the ID might be in order to kind of inspect agents later down the line, but we'll see if it gets to that. Now we're going to say A is a new agent. We need to give a data type, agent A, and we're going to say agents.add A. So that new agent we're going to add to our list of agents. Now if I press play now, it's going to be like, what? I can't find anything named A. When A gets made in this for loop, it's then immediately forgotten when we exit. And so actually I can't say A.display. Well, I can't say it yet. I need to make myself a loop. So I'm going to say for every agent, and I'm going to call it A, in, that colon stands for in agents, I am going to display that agent. And now every time I run the draw loop, 60 times a second, it's going to go through all of the agents and it's going to tell them all to display. So I've added all my agents in and I'm now displaying them all, so I should be able to press run, and we can see there that I've got a rather spread out group of agents. Now, can we see any? Some are touching. It looks like there's a few that are kind of have picked positions, and this will only get worse as we up the agent count. So I should be able to comfortably fit 1,000 on the screen. There we go. Look at that. Pressing one button and I've done 10 times the work. Yeah, so you can see all of these, there's some real overlap here with what they're doing. So what I'd like to do is kind of tidy up our code and make it so that nothing can overlap to start with. Everything is going to start isolated from each other. So let's have a look at how we can do that. Now what I'm going to do is I'm going to create a new tab. I'm going to put some of the code into a new file and I'm going to call it the community. Okay, so all of the agents will belong to the same community, and we will use the community to manage all the agents. So I'm going to press OK. So now I've got my main file where I make things kind of run. I've got my agent file which controls the behavior for each individual agent, and I've got my community which will bring this all together. Now I'm going to drag all of this and I'm going to put this in my community file. I'm going to take this and I'm going to put it in my community file, and I'm going to take this and I'm going to put it in my community file, and I'm going to start writing my community class. Now I'm going to say class community. Oh, also the point of order that all classes that you make should begin with a capital letter. It's kind of a programming standard. So you'll notice that in agent I've made that with a capital letter, community I've made that with a capital letter, and so when I'm calling a new something or other, so like in community where I say new ArrayList, that begins with a capital letter. Where I say new agent, I know I'm talking about a class because it starts with a capital letter. You would typically not start any variables with capital letters unless they were a class. So we've got ArrayList agent agents. So we're going to cap that there, and let's make our community. Sorry, I've dumped all this code in and it's made it a bit hard for you to see what's going on. In my brain, this all makes total sense, don't worry. So community, like that, and I'm going to set my agents in when I first start my community. Am I? No, when I generate my agents. Okay, so I'm going to make a function called void create agents, and that is going to create all of my agents. So I'm going to say agents equals new ArrayList agent, and that will create my list, and then we can kind of put in all the functionality to create all of our agents. So here, I'm going to take all of this and pop this in my create agents function. And sorry, formatting, it just has to be done, you know. So I've got this here. Oh, this has to be this dot now, so it belongs to this community. So this agents, let's get rid of that. This dot agents equals new ArrayList. This will be this dot agent dot count. Agent A equals new agent. This dot agents dot add. Okay. So in community we can say this dot create. Oh, not comma. This dot create agents, and this will create all of our agents for us. And we've got our agent count set at the top, lovely. And so the last thing we need to do is we need to just create a function that displays our agents. So void display agents, and we can pop that into here. Now I am preempting that we are going to have a lot of things that have to run in this community, so I'm going to create an actual function called run, and that will run everything that I want it to. So I'm going to say this.display agents and just in run, but as I add more and more functionality, then this run function will kind of become bulked out. Now the reason I'm doing that is that I can then hide all of my code in there, and then simply up here I can say something like community, the data type, and the variable community with a lowercase c. So my community data type attached to the variable name community equals a new community, and that will create me a new community. Now I'm just going to put that in here actually and put a colon here. Processing quite likes it when you declare a variable up here and then set it in setup rather than setting it straight away. Yeah, your mileage may vary, but it's probably a good idea. So I'm going to create a community of agents, and I'm going to draw every time I come around. I'm going to say community dot run, and that's all I need to do, and everything inside my run function in my community will run. And so I can up here, this I can pretty much leave now. I will come back in to kind of change a few bits and bobs, but really for this my functionality is there. I've got a community and I'm running my community every 60 seconds a time, and now I can press play and I should be back to where we started yet, but I've just kind of refactored my code and made it a little bit more structured. Okay, so what to do next? Well, the next thing I want to do is I want to make sure that when I create an agent they can't overlap, and so I would like to I'm going to create a function called is touching, twitching, and it's not going to be a void function, it's going to be a Boolean function, because the data type that I want to return from this function will be a true or a false value, because it will tell me if it is touching or not. And I'm expecting two agents to be given, so agent A and agent B, and we are going to check to see whether they're touching. Now I can say something like float distance equals, and I'm going to use the dist function, and I know that both my agents will have a position because I've given them a position up here, a p-vector of position. So I can say in here the distance between a.pos.x and a.pos.y and b.pos.x and b.pos.y. And this will check the distance between these 2 points, so this x and y position and this x and y position, and I can then check if this distance is greater. So if if the distance is less than a.width add b.width, then I know they are touching. Because if we have a circle, if we take their whole width and add them together, if that kind of diameter is smaller, then it's going to be a hit. I've explained that really badly. I do apologise, but there's going to be overlap if their distance is smaller than both of their diameters added together. So if that's true, then we're going to return true because they are touching. Else, we're going to return false. Now we will be using this in a few places, so this is quite a nice function to get done early doors. So I can give this two agents, A and B. I'm going to check the distance between them, and if the distance is less than their widths added together, I'm going to return true, they are touching, otherwise I'm going to return false. And so now, when I make a new agent, what I'm going to do is I'm going to add in a while loop. So in my create agents here, I'm going to say First thing I want to do is make my agent A equals new agent, and we're going to set its ID at 0, and then we'll start here from 1. So we'll add that there. Now for every other agent, we're going to do a while loop. So while, what should we call it? Something like valid equals false. Let's say valid position. While valid position equals false, we're going to set A to a new agent. So I've already declared it up here, so I can just reuse that A, and I'm going to say I'm only going to add it if it's not touching. So I'm going to say I'm going to loop through my existing list of agents. So when I is 1 here, we'll only have to do one pass through the list and look at the one agent that's inside it, this agent. Now the chances are they're not touching, so I will add a new agent. Then I'll come back to the top of the loop, I will increase by 1, and I will then again create a new agent, and I will check through the list. This time there'll be 2 in the list, and so I will check the first agent and then the second agent against my new agent that I've made and make sure it's not touching either of those, and it will keep going. So as this for loop gets towards the end of agent count, which is 1,000, it will be checking more and more agents to see whether it has collided with them. It's probably not the most efficient way to do this, but we're not looking for efficiency right now. Notice I said right now, and just not completely not, just now we're just trying to get it working. It's nice to be able to program without worrying about efficiency and then worry about efficiency at a later date. So for not ints, for agent existing agent in this.agents, we are going to check to see whether they are touching. So I'm going to say if this.touching, and we're going to pass in our A, because that's our new agent. Maybe I'll call this new agent. Yeah, maybe I'll call this new underscore agent, just to make things like clear, you know, rather than silly names. New underscore agent. So our new agent equals a new agent. For existing agent in our list of agents, if our new agent is touching our existing agent, then we don't want it. We want to make another one. If this.touching, so this needs to go in here. So this will result to true or false. And if it results to true, I can literally just say if this.touching, no, sorry, is touching. If this.is touching, new agent, existing agent, then do this. And I don't need to say equals true, because that's just a kind of nice thing you can do with if statements. You can leave off the equals true and it will still run. So I'm going to say if this is touching new agent, existing agent, then our valid position is going to be equal to false. And we are going to break out of the loop. So really, this needs to be Boolean. Boolean valid position equals false. So I need to take this now here, and at the top of my for loop, I'm going to say that my valid position is true. And only if we are touching an agent, the valid position will become false, and we will break out of this for loop. So this break will just break out of the immediate loop, so this loop here. And then we will circle back up to the while loop. Valid position will be false because we set it to false here, and we'll come back down. Valid position is true if we never touch anything, then this code will never execute, making it false. And so we'll come down here, and when we come back up to the top of the while loop, it will say valid position equals false. No, it doesn't. It's true. And so it will break. It will break out of that while loop. So I'm going to take this to agent. So I'm going to think carefully about where I should be adding my agent. So really, I can add it. Where's this? That's the for loop. You can see here when I click next to this bracket, it's corresponding bracket highlights. I'm going to pop it after the for loop. That seems reasonable. So we've got a while loop here, we've got a for loop, we've got an if statement. Just try and put some white space in here to make this easier to see. So we're going to loop through, we're going to make agents here. So this is make as many agents as in agent count. We are going to only allow agents to be made who do not touch, and that's what this while loop is doing. It's making sure that we have a valid position when we add our new agent. If we don't, then we come back to the top of the while loop and we replace our new agent with a new agent. Still at position I, because the for loop wouldn't have ticked across when we're stuck in this while loop. We'll keep going around here until we pop out and come in back into the for loop, and I will increase. So this now in create agents has become a lot cleverer, and I should be able to press play, and I've got an error. Forgot my semicolon. I will be forgetting a lot of semicolons from here on out, just because that's always what happens. Okay, this.agents.add new agent. Forgot to update that, and that will be the same. Let's copy that. That'll be the same down here. Yep. .add new agent. Okay. Renamed a variable halfway through. It's asking for trouble. Okay, I've got 1. Why have I got 1? Okay, so I added for I equals, did I put a 1 here? Yeah. I is less than this dot agent count, I plus plus, valid position equals false, while valid position equals false. Double equals, people, come on. Assignment operator and the, what is it? Single equals is the assignment, double equals is the comparison. Need to sort it out. Okay, now I've got nothing, but I think that's probably just because it's thinking about it. Let's give it a background. I haven't actually given it a background. Every time we draw it, let's say background, and let's give it just a nice white background. Not black, white. 255 for white. Why that's 255 is a lesson in binary that I'm not going to go into right now. Okay, we can see it's not turning white, so it's not liking something that I'm doing in here. So new agent equals agent I. For agent existing agent in this dot agents, valid position equals true. If this dot is touching new agent existing agent, valid position equals false, and break. Okay. Is touching distance equals dist, a pos. Distance is less than a dot width at b dot width, and that's the right thing, isn't it? Yeah. Return true. What am I doing wrong? I guess one thing I could do is put less than or equal to. No, it's not helped anything. What I will do is just be explicit in what I'm saying. So if that equals true, true. Nope, still not working. What's going on? I really don't know why this isn't working. Let's try this with like 100 and see if that makes any difference. Nope. Okay, for integer I equals 1, I is less than this.agent count I++. Valid position is false. So what I've got here isn't a syntax error. I've written all my code correctly. This while loop doesn't have a thing. Okay, I think I'm missing a certain amount of brackets. There we go. Okay, cool. I was missing a curly bracket off my while loop. I thought it looked a bit sparse down there. Okay, cool. So we can see that we're generating 100 here. It can't. They look like they're kind of almost touching, but if I do 1,000, we should notice that we get the same results, but nothing is touching. Now I'm getting nothing here, which isn't great. Maybe this screen is too small to support 1,000 that don't touch. Let's try 900. Nope. Let's try 500. Okay, they're clearly touching. What am I doing wrong? Create agents is touching. I'm passing in my new agent and my existing agent. This is so annoying. What am I doing wrong? So when I start my community, I create my agents, and I do all of the things. So I create my list. I make my first agent, and this is important because I need then in a loop an agent to compare with. Even if it's just one, I need to be able to compare something. Then I do my for loop. So for integer I is equal to 1, I is less than this agent count, I++, Boolean valid position is false, while valid position is false, new agent equals new agent I, for agent existing agent in this.agents, valid position is true. If this dot is touching between new agent and existing agent, if that is true, then valid position is false, and we break. And we add our. When do we add our agents? Inside the while loop. No, that's bad. Okay. That's very bad. Okay, I need to do it outside the while loop. That's why it wasn't working. Now, okay. Okay, that's a relief. I was being a silly Billy. So it really matters where this goes. This adding new agent. I was kind of going to all this trouble of finding whether a new agent was correct, and then I was coming down here and I was just adding it anyway at the bottom. So once we're outside of the while loop, outside of these curly brackets, we know that we've broken out of this loop, which means that we've got a valid agent that we can add. And you'll see here that with 1,000 agents, none of them are touching. And I should be able to maybe push it to 1,100. Let's see if that will work. Yep, maybe try 1,200, dare I? Okay, and you can see that every time I generate this, it's a fairly, they're not going to be in too much of a while pattern because they're just filling the screen as much as they can. But you can see there that there are no collisions. Every time I run this, we have managed to make something where they do not touch each other. They are isolated from one another, which is great. Okay, so now what we want to do is think about something that can move. So I'm going to have a boolean, and we're going to call this is mover, and it's going to be set to I don't know if it's going to be set to anything. We might pass it into the agent, but we're going to say this dot is mover, sorry, is mover. We're going to say that is equal to, and I'm going to pass that in when I make it. So boolean, I'm expecting is mover, and I'm going to set is mover to is mover. So this dot is mover will equal whatever I pass in when I make the agent. And in community, let's set a count of movers. So int movers, let's set that as a constant. Movers equals, let's set it to 5 just for now. And when we create our agents, let's think about this. Up here, let's make mover count. So we're going to count how many movers we've made. So int mover count equals 0. And down here, we're going to new agent equals new agent. So we'll say if mover count is less than this dot movers, then new agent equals agent I and true. So it's gonna be a mover. Else we're gonna say exactly the same, but it will be false. So that won't be a mover. And so we can select a certain number of our movers to be a certain number of our agents to be movers, things that can move around the screen. So most of our population, our community, is going to be isolated, but we will set a certain amount of them that will be movers. So if mover count is less than this dot movers, and then down here, when I add our new agent, I'm just going to say mover count plus plus. So I want it to add 1 to itself. And so let's come down here, void display, let's make a move. So void move. So if it is a mover, it will be allowed to move. And the way it moves is we can just say something like p vector movement equals new p vector with a random, what do I want, between like -10 and 10 maybe, and another random between -10 and 10. So it can move any way in x and y between -10 and 10. And that might be a bit of a big jump, we'll see. And then all we have to do is we have to say this.pos.add, and because we've got a p vector as our position, we can just add that movement and it will sort it all out for us. We'll add the appropriate x and y's together. So that's our move function. Now in community, when we display agents, really what we want to do is we want to just do a quick check. So we want to say if a dot is mover, is that what I called it? Is mover? Yeah. If a dot is mover equals true. Now you don't have to put equals true, but do you know what? It just feels weird now. Then what I want to do is, no, he can come back. What I want to do is I want to say a dot move. So only if they're a mover. If a is a mover, if that's true, then they can move. And all of them, regardless of what they are, they're going to display. And so now we should see, I've set the amount of movers to 5. We should see 5 Nope, missing a curly bracket. Found an extra bracket character without a bracket to match it. Okay. Oh, does that match? Okay, I seem to have. Is that going to appease you? No, expecting. Oh, I see. I forgot one there. So now this is too much. The constructor social isolation.agent int is undefined. Cool. So I need to make this with false. So I'm gonna. I set my mover count to 0 down here. So I'm gonna set 5 movers in here. Mover count plus plus. Hopefully I've done this in a way that means that I won't end up with everything being a mover. Let's have a look. Cool, 1, 2, 3, 4, 5. I've got 5 movers, lovely. And they are all just kind of dotted around, and you can see that plus minus 10, that minus 10 to 10 means that they can really kind of just move in a very erratic and odd way. But they are moving, and we have got 5 agents that are capable of moving, and they are moving every kind of time we're drawing the screen, and the rest are staying socially isolated. This is great. So what I want to do now is have a look at how we can stop them from going off the screen quickly. So agent move this.pos.add movement. I'm going to say if this.pos.x is less than 0, I'm going to say this.pos.x plus equals 10. Okay, so I want to, it could be as much as minus 10 off of the screen. So I want to add 10 back on so it comes back onto the screen if its x position was less than 0. Else, else if this.pos.x is greater than the width of the screen, then I'd like to say this.pos.x minus equals 10. And that will take 10 away. So if it's 10 off of the screen, we'll minus 10 and we'll bring it back into the screen. And I'm just going to copy this whole if section and pop it down here and do the same for y. So if this.pos.y is less than 0, this.pos.y plus equals 10, this.pos.y is greater than height, need to change this width to height, then this.pos.y minus equals 10. And this should now stop any of the movers from going off the screen. And if they do, they should just kind of constantly bounce back, which is quite nice. So they should all, you can see this one here flitting around, it's not actually able to go off the screen. It's staying on the screen, which is nice. They do, yeah, see this one as well. They do have a tendency to kind of stick around the edges, which is a bit odd, but hey ho. So we've got things that move now. This is great. What we really need to do now is think about how we can infect these agents. So I'm going to have a Boolean is immune, and we're going to think about how we can, or what we can do to think about them being immune. I'm going to have, what else am I going to have? I'm going to have a Boolean is infected, and I'm going to have an should we say an infection? Let's have an float infection, and let's also have a float health. Okay, cool. So now we can start thinking about one of these actually carrying a disease and being able to pass it on to someone else. Now, we've got a population here. We've got some things that are moving. Now, when I display my, what are they called? My agents, I want to display them at certain colours. So my infection rate, let's set that to 0 to begin with. Okay. And I'd like to draw this at float red, float green, and float blue. And float red is going to equal 50, add whatever my infection is, this dot infection. And my float green is going to equal 50, add whatever my infection is. Actually, maybe I'll just do equals this dot infection for green, and I'll do blue equals 200 minus whatever this dot infection is. So it will slowly turn from less blue to more red. And to test this, how can we test this? Well, we need an infected count. So in my community, I've got an integer of movers here. Let's also have an int of starting infected. So the amount of agents in my population that will start infected, and let's start that at 1 for now. Okay, so just one agent will start infected. So when I make my agent here, I want to say boolean is mover, and I want to also say boolean is infected. And down here, I can say this dot is infected equals is infected, and that will allow me to, in my community, when I make my agent, be able to tell it whether it's a mover, be able to tell it whether it is infected, and then it can make decisions based on whether it is infected or not. Okay, so for instance, let's do void progress infection, and we can say if this dot is infected. I'm not going to put equals true. You know what? Let's do this properly. If this is infected, then we're going to say this dot infection plus equals random between 0 and 0.1. So it's a slow going disease. And then before we display every time, should we need to, we will progress the infection. Now up here, when we make our first agent, I can say true, and then down here I can say false and false, because remember, up here we are expecting it to be given a third boolean, so an integer, a boolean, and a boolean. And so here, when we make our agent, we have to give it an integer, a boolean, and a boolean. An integer, a boolean, and a boolean. And now we should see that one of my, oh no, the function is infected does not exist. Oh, sorry, it's not a function, it's a property. So I shouldn't have put the brackets after it because I can't call it, it's not a function, it's just a boolean is infected. So I'm just checking if this is infected equals true. So if I do that, so we should see one of these start to change colour. Now it's going to be a bit of a needle in a haystack situation. Let's see if I can find it. It's not jumping out at me. Is it? No, it's not that one. Could be just barely on the screen actually, thinking about it. That first one we made. Okay, let's do it to all the movers instead, because this should be working. I feel like I programmed this right. So instead of making this one true, let's make this false, and let's say that all the movers will be infected. Let's try that. So we should see them changing color. Maybe. There's something really stupid I've forgotten to do, isn't there? If this dot is infected, this dot infection plus equals random 0.1. This dot infection. I don't know why this isn't working. So it's still being displayed. Still moving. I think I need to put this dot progress infection. Will that change anything? No. Okay, so that's not changed anything. What am I doing wrong? They're all displaying because they're all being drawn. Oh! In my fill, I'm still filling them with 50, 50, 200. I need to be filling them with my variables, red, green, and blue. Do you know what? I see students do that in class so much, and it's always really obvious to me when I've not written the code that they've done it. But I appreciate that when you're in the thick of it, it is like trying to see the wood for the trees. So okay, so now when I run this, we should see that our movers slowly change colour compared to the rest of the population as their infection increases. Now, I've just kind of done this arbitrarily, so it doesn't really mean much right now, but I just want to get across the idea that we have this number that is increasing and changing. They're moving quite a lot, which is hard to tell, but it does look like they've changed colour. Yeah. Okay, great. So we've got them changing colour. And what I think I will do is I will say progress infection, this dot infection plus equals random 0.1. If this dot infection is greater than 100, then we are going to say that this dot is infected equals false, and this dot is immune equals true. So it will stop being infected and it will now be immune. And if it's immune, we will draw it slightly differently. So here, progress infection, we will say that RGB will be equal to if this dot is infected, or no, actually I just need to say if this dot is immune equals false. So if it's not immune, then we're going to draw it with its infection rate, so those values for R, G and B. Else we are going to set R, G and B to other values. So I need to declare these up top. Float R, float green, float blue, and then here we can get rid of the floats. And here we can do the same thing. So R equals, I'm going to set them all to white if they are immune. So R, G, and B. Okay, so we're going to progress our infection. We're going to make our red, green, and blue colours, and we're going to change them depending on whether they are immune or not. So once the infection has run its course, they will then become immune. If this dot is immune equals false, null pointer exception. We haven't set is immune. So is immune will always start false. No one starts immune to this. So we should see these gradually change colour now, and once they have changed colour, we should then see them actually just go to a white. So they're definitely turning a kind of redder hue. Are they going to turn immune? This dot infection is greater than 100. This dot infected equals false. This dot is immune equals true. Ah, yes, they've turned white. Okay, fantastic. So we now have a system to check whether an agent is infected. If it is, we're going to change its color by a small random amount. And once it's immune, we are going to change it to white. Now, the idea of the simulation is that anything that changes to white will have caught the virus, and anything that stays at its original color, that kind of bluish color, is going to be healthy and unaffected. Now, what I want to do is I want to get some stats up on the screen now before we start infecting everything. So I'm going to write a quick function just above run. Doesn't matter where I write it, but I'll just write it up here. Void show stats, and show stats is going to show some stats. We're going to use the text function, and we're going to use the text function to write certain stats. We have to give it a string, and then we have to give it an x and a y position. Now my x position is going to be something like, I don't know, 20, and my y position is going to be the height, because I'm going to draw them at the bottom of the screen. Or should I? Maybe I'll put them at the top of the screen, that'll be easier. My y position is going to be, I don't know, 10. And let's think about this. Let's make an int x equals 0 and an int y equals 0. Now, this is really over-engineered here, but I'm going to put in x plus 20, y plus 10, and this means that if I wanted to shift them across the screen, I could change this x and y, and I could move my, because I might end up with quite a blob of things here. So my first text is going to be population, and that's going to be plus the string of, and I should have this dot, what did I call them? This dot agents. Cool. So all of my agents this dot agents dot size. I'm going to get the size of those agents. So now let's just check that's working. No, because I'm not calling it in run. So as well as displaying the agents, I need to also say this dot show stats, and I should now be able to see my population. Cool, so we can see up there, population 1200. Now, I will just do a text size and set that maybe to 20, and I will also bring this down a little bit, so y add 20. Cool, so I've got my population. Also, I'm probably just going to kind of change the fill of this to black, maybe. Okay, that's not ideal, but it's okay for now. We get the gist. So population 1200. Now, what I'd really like to know is how many agents are infected at any one given time. So what I want to do here is I want to really count infected. So I need to make a void count. No, not void. We're going to return an integer. Int count infected, and we're going to say that for agent A in this dot agents, if A dot is infected, let's int count equals 0. If A dot is infected, A plus plus, sorry, let's do, count plus plus, and that will add to our count. So now I can grab this text line, and I can say infected string, and I'm going to just call this dot count infected. And right at the end of this function, I'm going to return count. I have to return something. If I put something that's not void here, it has to have a return. So I'm going to return that count integer. So this dot count infected, don't need a semicolon there. So now I should have an infected count. Nope, it doesn't like that. Count infected, okay, I need the brackets at the end. There we go, because it's a function, so I need to call it with those two brackets. So count infected, do that function, Okay, I've drawn this at exactly the same place, which is useless. Let's do y plus 40 instead of 20, so it's 20 down. Okay, so we can see there, infected 5, so it's counted our 5 infected. And as we kind of come through this, we should be able to see that that number drops down to 0 as they all become immune. So let's also make a count immune, and let's draw that at y plus 60, and let's say immune, and let's just copy this. But instead of is infected, we're going to count if they are immune. So let's play that. Doesn't like that. Why don't you like that? Duplicate method. Count. Oh, I didn't change the name. That's very lazy of me. Count immune. Okay. So I've got 0 immune, 5 infected, and I've got 1200 population. So in a second, we should see the simulation actually shift, and we get a reduction in the infected and an increase in the immune. Slowly getting there. Anytime now. Okay, here we go. Okay, so we can see there that the infected have come down to 0 and there are 5 immune. Okay, this is great. So instead of this.agents.size, this is the population. What I'd also like to find out is the healthy population. So so maybe I should make this total population, and we are going to say, should we say uninfected? I'm going to say healthy, but that means uninfected. It doesn't mean that infected or immune are not healthy. And that will be this dot. Can we do something clever here? If we know the infected and we know the immune, let's do something slightly clever. So let's say int infected equals that, and then we're going to write the string of infected. We're going to say int immune equals that, and then we're just going to print the string of immune. Now I'm getting conscious that every time I want to counselling I have to loop through all the agents and do a little check, which is not great. I was thinking about checking if they're immune and infected in the same function here, while so to reduce it to one loop, but that's alright. But to do some quick maths, I'm going to say int healthy equals this dot agents dot size minus infected minus immune. So that will give me my total amount of uninfected, unimmune, healthy population. And then up here, my healthy thing, I can just say print the string of healthy. And that should give me, okay, I need to change my y here. So this can be 40, this can be 60, and this can be 80. Don't forget the semicolons, and away we go. So now you can see here we've got affected 5 and a healthy the healthy population is 1195, which added together makes 1200. Lovely. Okay, this is great. So now what I'd like to do very quickly is just show you that why I've put this x and y in. So I've put in these kind of x and y. What's the point? Well, if I wanted these to be at the bottom of the screen, I could just change y to something like how tall is it? 1000. Change it to something like 900, and then bosh, I've pushed them all down and I've only had to change one number, and it's just really easy to move my stats across the screen. I'm going to keep it at 0, but in the future, if I want to move these around, that's kind of built in. So I've got all my stats that I want to see right now. Now the last thing I need to do is just look at how I can infect agents. So let's have a look. Where would be the best place to do this? So a.move. So every time an agent moves, really I want to check whether it is touching. So I want to do a.move, and then I'm going to say for agent A, no, I've already done that, agent for agent, what should we call them, other in this dot agents, if other does not equal A, I'm really sorry for calling this A, but it is what it is. If the other is not equal to A, so if it's not itself, and this dot is touching other and A. So if other is not A, so if it's something else and they are touching, well, then I need to do some checks. So if A dot is infected, if A dot is infected and other dot is infected does not equal true. No, sorry, let's do equals false. So if A is infected, so if the thing that isn't moving, although it could be moving, if A is infected equals true and other dot infected equals false, then other dot is infected equals true. So A has touched other and it is now infected. Else, if A dot is infected equals false and other dot is infected equals true, then if our kind of mover isn't infected, but if our normal one, no, if our mover isn't infected, but it has moved on to something that is infected, then it will become infected. So A dot is infected equals true. And so this will pass the infection on now. And so now if I run my simulation now, I think all my movers start infected. Yeah, so you can see here the infection rate is going up as these are moving around the screen. Okay, and we can see that our healthy population is dropping and our infected is rising. Now I've put immune here. Obviously, I've not really thought about death or anything. Trying to keep this fairly positive, but we can see this whole population here is slowly changing colour in the area of where these movers are. healthy is still dropping. They're still infecting new people. So you can see on a population of 1,200, just with 5 moving around, they have infected a significant amount. Everyone else is isolated, but because they've come into contact with these 5 that are moving around, they have been affected. And obviously the paths on these are random, so it's not the most accurate simulation, because this might be a librarian or something that always goes from the library to home, and so wouldn't come into contact with all of these people. But just as a kind of general overview of how something moving could transmit a disease. You can see here, now they're immune, they're not actually spreading the disease. More research needed on that, I guess. I don't know if you could still spread it once you've recovered from it. I guess if you're not fully recovered you could, but I'd imagine that once you're immune. If you can become immune. I'm guessing you can, I'm hoping you can. Okay, so we can see here that our infected count is slowly dropping off, and we've lost about 400. 400 have been infected. Now, you can play with this. You can play with how many movers you start with, how many starting infected. I haven't actually put in the starting infected, have I? I've just kind of made all the movers true. So let's set this to false initially, and then let's do this dot infect agents, and let's create that. So let's just do it under community. So void infect agents, and what we're going to do is we're going to say that will loop through all of my agents. So I'm going to say agent. I'm not going to call it A, I'm going to call it agent in this dot agents. I'm going to say let's pick a random number. Float r equals random between let's floor that random number. So floor means that round it down to the nearest whole number, rounding it down, never up. So I'm going to take the floor of random 10, and I'm going to say if r is equal to 1, then I'm going to say that agent dot is infected equals true. I'm going to increase infection count. Let's do a int infection count equals 0, and we'll bop that up to 1, infection count plus plus, and we will say that if infection count is greater than, what would it be greater than? Starting infected. So this dot starting infected, let's say constant, starting infected, then what am I going to do? I'm going to, if infection count is greater than this dot starting infected, then I'm just going to simply break out this loop. So I want this for loop to stop if my infection count is greater than this dot starting infection. And this will allow me to infect a random sample of my population. So now if I hit run, it doesn't like float. Okay, it's missing a semicolon, I think. Now if I hit run, I've got 2 infected because I did less than, not less than or equal to, or greater than or equal to. So if I put an equals there, it will actually only infect 1, like I told it to. Yeah, infected 1, and you can see here starting infected 1. So I've added in a little bit of logic and I've put in this random number so that there's only a 1 in 10 chance of being infected. So it doesn't just infect the first agent that is made, it will just select a random proportion of the population. Now the one that is infected, I don't know where it is, but it's very possible that these 5 movers won't come into contact with it. And in that case, then the amount of movers has a real big impact on whether this disease will spread. However, obviously, if there it is there. So there's our first infected, and we can see that it doesn't look like any movers are going to come into contact with it. Now, if a mover did come into contact with this person, then they would be a vector for that disease and they'll be able to spread it off. But at the moment, there's not really that many that are in proximity, and this is going to become immune quickly. There we go, it's immune, and so actually it's fine. Social isolation worked. This person was able to stay, and now the disease is gone. But let's say that we have 50 movers. So the way I've programmed this is really nice. That I can just change these numbers at the top, and that affects the whole program, and it just works. I don't have to worry about all of the logic in here. I can just hit play, and I will have 50 movers on my screen. So now I've got 50 movers all moving around. I don't know where my infected person is yet, but I'm sure they'll show up in just a second. Now, obviously, the chance of this being spread now is much higher because I've got 50 agents moving around the screen rather than just 5. Infected, yeah, you can see the infected count is really going up now. Even though we only started from 1 infected person, having this many people moving around and interacting and coming into contact with others is really spreading the disease, and we can see here that the infected is rising up real quick. Okay, that's much more than we had in when we had all the movers infected, just 5 of them. That had a lot less impact than just having 1 infected but 50 movers. So you can see here that things moving around the screen are actually much more likely to infect the whole population the more movers we have. With even starting with just 5 movers but having them all infected didn't affect the population as much as what we're getting now, which is a lot of the population being affected. You can see here we've almost infected the whole population. We're almost at 100% of infection here. So healthy is dropping 72. Maybe it'll stay. Maybe no, 68. It's dropping. I'm really glad we put that count in. I did a practice version of this and I didn't put in a count of the healthy, but actually that's a really nice stat to see. You can see that dropping down. So you can see here, look, the swaths of people that have been affected by this, all of the agents, they're all getting kind of infected. I'd be very impressed if those 48 managed to stay healthy. Because everyone else, when they have caught it, is staying isolated, we are getting these kind of people in here that are managing to stay. Oh no, he just got infected. They are managing to stay kind of healthy, but these movers, man, they're not good. These people moving around and interacting, you can see here that these two look like they might be safe. All of these are immune now, so it's not too much of an issue. These two are staying socially isolated, so it's okay. And we can see that we've got 24 of our population. It doesn't look like any of our movers are infected. In fact, that would be a pretty good stat to add, an infected movers. Now, this video has gone on for way too long, so I'm going to stop it there. Have a play around with the code, maybe change your agent count, your movers, the amount that starts infected, and start having a little play with this simulation. That's the beauty of making a simulation when you program it, is that you can really play with the numbers and see what different scenarios evoke different things. So you could kind of take our lockdown scenario, maybe kind of 10% of the population is infected, but only 1 person can move around. How does that differ to 1 person being infected, but 50 people moved around? Well, I've just done that simulation, but what if the population was less dense? What if this is kind of a London area where everyone's kind of densely populated, but what if this was the countryside where the population might only be 100? Then what if like 1 person's infected and 5 people are moving, or 10 people are moving? Does that still have an impact on the population like this has had now? You can see now everyone has either been infected or not infected. These people that stayed still, there are 23 of them that managed to stay healthy. The rest got infected because of the movers. I don't know how many movers started infected. In fact, what I'm going to do is I'm just going to add in a stat for movers infected, and I'm going to end this video. So I'm going to do int count immune. Count infected movers. So I'm going to pinch this loop here, and I'm going to say if A dot is immune and A dot is mover. Is that what I called it? Is mover, yeah. If A dot is mover, then count dot plus plus, and I'm going to say int infected movers equals this dot count infected movers, and then let's add this on. So infected, and let's copy that, change that to 80, change that to 100, and I'm going to say infected movers string. Let's copy that. Okay, so if we run the simulation again, we should see that we have 0 infected movers. Wait, but how's our infection going up then? Wait, is immune. No, I don't want is immune, I want is infected. Okay, so here we go. We started with 1 infected mover there, I think. So let's play that again. 0 infected movers, and we've got 1 infected. So now it's just a waiting game to see whether a mover gets infected. And obviously with 50 movers, the likelihood of one of them touching it is much higher than when we had 5 movers. So the amount moving around the screen has an impact. Now at the moment, actually, we're doing okay. None of the movers have been infected. This person is infected, and it doesn't look like, oh, hang on, 2 infected movers. Suddenly the infection is rising and it's soaring. Okay, yeah, this is going south now. So I'm going to leave you there. Hopefully you'll be able to put your own simulation together using this video, and you could probably present it in a better way. You might want to kind of change how your agents look, how they behave. You might want to change how the stats are formatted. You might want to pull some other stats out of the program. You might also think more carefully about how the movers move. Maybe a more kind of clever way for them to move around the screen rather than just doing this random kind of almost like a buzzing fly movement. You could also think about the colour and what I'm doing. I also added a health to the agents that I never really got around to implementing. But I guess you could then start looking at kind of mortality rates and whether they survive it or not, and you could maybe start adding pre-existing conditions to your agents and start randomly generating like little backstories for them. But that's going to take us the rest of the day, and this video is already long enough as it is. So I'll leave you there. This is a really nice thing that you can do with Java or a lot of programming languages, but because processing is so visual, it allows us to make these lovely simulations where we can pretty much simulate anything. And you can see here, this epidemic has come along, and I've been able to just kind of make a simulation to mimic the kind of passage of disease through a population, if you like. And you can see here that even though we started with just 1 infected, these 50 movers, 8 of which are now infected, have really devastated the population. And so you could have this, and you could make an argument that social isolation is a good thing and is in our best interests. The less people moving around and interacting, the less the population will be infected. Sweet.